Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are starting with the next topic of the unit D, grade 11 chemistry. This is the last unit for this, and we're doing the today's topic, which is the gravimetric analysis. In the previous lessons, we completed with the stoichiometry thing. Now we're doing the gravimetric analysis, and we're doing the titration thing. So that was like the end topics of this unit, and then we finally completed with the grade 11 chemistry. But the today's topic is very important topic. We are doing a method called the ICE table. This method we are also doing in grade 12, but now we are just introduced with that ICE table method. So firstly, before going to that portions, we have to know about what is the qualitative and the quantitative analysis. So the analysis of known chemical subsample, unknown chemical sample can include the qualitative analysis. Qualitative analysis is the identification of a specific substance which is present. Any specific amount of substance which identification can be present is called the qualitative analysis. And the quantitative analysis is the determination of a quantity of a substance. So it's a quantitative, so it's like basically the quantity which determine the quantity of the substance which is present in any unknown sample. Examples of qualitative analysis is the calorimeter. Calorimeter is very important thing which is help for the flame tests. Solution color test is help for this, and the selectively precipitation reactions. Then quantitative analysis included derivative analysis and the titration analysis. Titration analysis we're doing with this topic with in our upcoming lessons, but today's lesson is more focused on the this derivative analysis. For this, we have to know about two things, which is the reagents, which is the limiting and the assess reagent. So limited and assess reagent are the different things. The thing which are in a limited amount is called the limiting reagent. The thing which is in an excessive amount is called the excessive reagent. So limit reagent is the reactant whose entities are completely consumed in a reaction. When we do the reactants, when do the reaction, in the reactant, there all the entities can be fully consumed in the product side. In the whole overall reaction, this is called the limited reagent, meaning the reaction stop when all is reactant is used up. When all the reactant used up, the reaction will stop. It's called the limiting reagent. The cess reagent is the opposite of this, that whose entities are present in surplus amount. We have a surplus amount of their entities. So that some remain after the reaction ends. After the reaction, there are some amount which will left. That's called the assess reagent. And this is the method to how to solve the questions of the limiting and reagent, limiting and assess reagent questions. But we go through with the question, and I will tell you how can you actually solve and actually find out which thing is limiting, which is the assess. Done. So the question says, if a 10.0 grams of copper is placed in a solution of 20.0 grams of silver nitrate, what mass of silver will be produced? So from this question, you will see that you will think that this is type of a stoichiometric question, but no. We have to consider something else because they only give us the masses. They don't give us anything else. That when we want something else to find something. Then, so we want the mass of the silver. We can't find the mass of silver directly. We have to do something in this. So the copper is placed in a silver titrate. So we have to write the equation for this. So copper, which is Cu, which is solid. This silver nitrate, so this is +1 is -1. So we have AgNO3, which is the soluble. So you can check by your solubility table. Now this is the single replacement reaction. So this goes to CuNO3 2, and this is the aqueous again plus Ag solid. Now I have to quickly balance this. So balance this 1 2 over there. So this is a balanced thing. So we have a mass for the copper which is 10.0 grams, and we have a mass of the silver nitrate which is 20.0 grams. In this type of questions, they always given you the masses of the reactant side because they are only limiting assess reagents are on the reactant side, not on the product side. So the limited and reagent, limited and assess reagent, how can we find that what is the limiting and what is the assess? For this, we have to find the number of moles of both. So here we have a mass, so we can find the molar mass of this. So copper's molar mass is 63.55 grams per mole. And for AgNO3, molar mass is about 169.88 grams per mole. So these are the molar mass, but in this is a topic that where you can't find by the like mass upon molar mass. You can't do like this. In this type of sum, you have to do something else in this. So basically, when you do m upon mass upon molar mass, you will get about like you divide this both, you will get 0.515735 moles. Done. Now I have to divide this by the moles which are for the copper. That how many coppers are there? There are only one copper over there, so we have to multiply divide it by the 1 mole, which stays the same, but in some cases, like in another case, we have that something moles over there, and that's your proper mole thing. In this too, when you divide this, the mass upon molar mass, you will get about 0.1177301 moles, which is divided by not 2 moles. We have a 2 AgNO3. So divided by the 2 moles, and when you divide this, you will get about 0.05886 moles. Now this is your final moles for this, not 0.117. Then now for the both moles, the which thing is very smallest is called your limiting agent. Write it this. This is your limiting agent, which is an AgNO3, and so this is your accessory agent. You have to write this thing, like this is the limited agent, this is the accessory agent. You have to write this. Now our goal is to find the mass for the silver. You can find the mass for silver. So for the basically for the silver, you have a mass. You have to find what is the molar mass for this. Is about 107.87 grams per mole. You can see from your periodic table. Okay? So you have to find the n for this first. So the thing which is the limiting reagent, that moles you can use to find the moles for the Ag. So you, and that one thing more, that this thing you already find this thing for to find the what is the limiting and what is the cess. But you have to use the actual one which you use in the like a stoichiometry questions. You have to use this thing, this and this number of moles of the silver of the AgNO3 to find the silver's number of moles. So for the n of Ag, 0.11773 multiplied by 2 divided by 2. So you will get the same thing, which is 0.11773 moles. You can put over there, so 0.11773 moles. You'd find the mass for this. So molar mass divided by the n number of moles. You will get 12.69 grams, which is basically the 12.7 grams of this. So this is your answer for this. So you can see this type of thing is very trickier because to find the Eg number of moles, I repeat it again, you don't use this. This is only for to find the limiting reagent or the accessory reagent. You have to use the first thing which you divide this thing and you get this. So you have to use this to find the Eg's number of moles, that's silver's number of moles. Done. So that's the small things in this very matter. You have to know this. Done. The next question we have, this question is basically the ice table question, that where we have to make a proper ice table of this. So the question says, in an experiment, 21.5 grams of sodium hydroxide in solution is combined with 26.8 grams of silver third chloride in solution. What mass of the accessory agent remains unerected? What mass of each product will be obtained? So there's just something extra we have to find, which is the mass of the accessory agent thing. What's that thing? We will find that very quickly after that. I will tell you how can we find that thing. But basically, to find the mass for the each product, the product we have to find that thing. Done. So basically, the ice table works in this. So how the ice table works? But firstly, we have to create the equation. We balance this. We have to find the limiting and accessory agent, as we find over there. Then the same process we have to follow at the first. So what's the reaction? So sodium chloride hydroxide with the iron third chloride. So it's basically NaOH, which is aqueous, plus FeCl3 aqueous, will get NaCl, which is again aqueous, plus FeOH3. This is double replacement thing. The quickly, like we have to like balance this thing. So this is balanced. So we have the mass of the NaOH, which is 21.5 grams. We have the mass of FeCl3, which is 26.8 grams. Find the molar mass for both. So this has the 40 gram of mole. You can separately find and then plus them. You know how to find. And for FeCl3, it's about 162.2 approximately grams per mole. Now you have to find the molar. So divide 21.5 divided by 40, you will get 0.5375 moles. But now you have a 3 of that mole, so you have to divide this by 3, and your final answer is 0.179166 moles. For this too, 26.8 divided by 162.2 grams per mole, you will get 0.165228 moles. You have to divide this by 1 mole, because there's only 1 over there. Your final answer will be 0.165228 moles. Basically, you have to find the mass for the both. So you have to find the mass of the NaCl and also the mass for the FeOH3. So the molar mass for NaCl is 58.44 grams per mole. And for the molar mass for FeOH3, you get 106.88 grams per mole. So what's the limiting reagent from that both? Yeah, this one. So the FeCl3 is your limiting reagent. And the second one is your assessed reagent. So basically, how can we have to make the ice table? So how can you make that actually? So you can make that thing. So that's thing. And basically you have ice thing. So this is the 4 things. So I have to short this thing. So here you can write your ice. So ICE ice. I will tell you what is that thing. So I have to divide this like this. And there are the 4, 2 reactants and 2 products. So 2 for the reactants and then for the products. So that's how the ice table works. Then there the first 2 boxes are for first 2 rows are for the reactants and others are for the products. Firstly, C means that the initial thing, that what we have that initial. So at the initial, what we have? At initial we have this thing in terms of n, okay, in terms of n. So in fact we have this. So I have to write these values in over there, not these ones where we find the limiting reactants. We have to find the before that thing, the mass upon molar mass, that thing. So it's 0.5375 moles we have. For this we have 0.165228 moles. And for initial, for the NaCl and FeOH3, we don't have things, so we kept it as a 0. Then now C means change. The change thing, we have to find the change thing now. The change means that how a change in this. Then you have to basically you have to change. In the reactant side, we have to do the suppression. In the product side, we have to do the addition. So in this, we have to do the suppression thing. Done. So basically, what's going on in this? We have to multiply this thing by 3. This thing multiply by 3. Why? Because we have an NOH. We have NOH. You have to multiply this by 3. Or you can also see like this. Yeah, you have to multiply by 3. So when you multiply by 3, you get minus 0.165228. Because you do minus 0.5375 multiplied by 3, so you get a minus in this. In this, you have 1. So you have, when we multiply this by 1, you will get a minus 0.165228 moles. Done. So this thing and this thing, this minus, and you get the 0. Because they plus minus, you get 0. In this, you do the same thing, plus. In this, you have to use this thing of the limiting reagent. This thing. In over there, we also use the limiting reagent thing. We will get that thing. And over there, you have to use the limiting reagent thing. So 5228 moles. And over there, 2. So 5528 moles. Here we have multiplied by this by 3 because we have over there 3 thing. One thing I will wrong over there, that multiply by 3 or multiply by 1 you have to do over in this step, in the change step. Because when you do in the E means the equilibrium, you will get your answer for N. When you multiply this by 3, you will get 0.041856 moles. And after that, you can find the actual the mass. Because the mass, they want the mass for the reagent which remains unreactive. You have to find the mass for the NOH in the ice table at the end. We have that mass, but the mass which is left, we have to find that mass. So that mass, we have the change in mass, we have change in number of moles. You do molar mass vary by the n, multiply by n, you will get about 1.67 grams of this. And this is your final answer for the mass which is unreactive, the cess mass. This stays 0, and for the other two, the product side, you'll find the mass for the both. So for this, n is 0.495684 when you multiply this by 3. And for this, you stays at 0.1652228 moles of this. You'll find the mass for this. So molar mass multiplied by the n, molar mass multiplied by n. You will get about 29.0 grams of this. Molar mass you find over there, these two, and the n you find over there. For this, you will get 17.7 grams. So these are the answers for this. This is how the ice table works. But the main ice tables you do, we will do that in the grade 12 chemistry. In the, I think the first chapter or in the last chapter, we'll discuss that thing in the grade 12 chemistry. For now, you have to know about that much only. So that how the derivative analysis works, and the ice table is very important in this. Limited reagent quotient, saturation reagent quotient is very important in this. So that's all for this lesson. In the next lesson, we'll start with the some experiment part with the theoretical and actual yields we want to know in this. There's such a short topic we discuss in the next lesson. So that's all for this lesson. Let me say EduVibe, learn smart, not harder. Please like and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till it's related with EduVibe.